Alrighty. So now we are going to start. I'm sure I still have this on. Yep. Now we're going to start with reflection. This is the reflection worksheet. It should be 3.2 on Canvas. We're going to start with reflection. Basically, what reflection is, if you can't tell from the crudely erased drawings from earlier, um, whenever we're dealing with reflection, what we're doing is we're creating an identical image of an object, but we're creating it on the other side of a particular line. We're creating it on the other side of an artificial barrier. And there are a couple of ways that we can do some of these. What I'm going to do is I'm going to show you kind of the easy way to do it, and then I'm going to show you the one that's got a little bit more, I'm not going to say math, but it has a little bit more memorization behind it. So let's take a look here. So the first one, we're just going to graph this out. So A is -4, 2. So 1, 2. So 1, 2, 3, 4. 1, 2. All right, so there's that poorly erased point. Oh, wait, 2. 1, 2, 3, 4. 1, 2. There we go. It's +2. I was going to say I'd ask editor Richard to deal with that, but something tells me he's in a pretty foul mood today. So B is 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Alrighty. Yep, there we go. 4, 7. So that gives us A. That gives us B. And then point C is 5, 1. All right, 1, 2, 3, 4, 5, and then 1. And we're going to draw this back in as it was crudely erased before. All right, so what we've got is we're reflecting it about the x-axis. So what that means is we're going to take this x-axis and we're going to create an identical image to this one, but it's going to be like a pancake on the other side, but it's going to be flipped on the other side. So B is going to be, well, anyway, there are a couple of different ways to do it. This is the easiest way, this is the most direct way, and it's the way that I would recommend if you get something like across the x-axis or across the y-axis. So in this case, what you do is you find out how far away, because we're dealing with the x-axis, that means that the x positions aren't going to change. It means that A is always going to be as far away from the x-axis as it is, as far away from the y-axis as it's always going to be. B is going to be as far away from the y-axis. Basically, these aren't necessarily going to change. They're just going to be one. They're not going to change their x position because we're flipping about the x plane. So what it means is that they're just going whatever this is, whatever this distance is between the x-axis and this point is going to be the distance between the x-axis and the reflected point. So in this case, it's going to be, this is the x-axis, so this would be point C. This one, B, is 1, 2, 3, 4, 5, 6, 7. I don't know why I counted, it's right there. So that means that B is going to be on this line and then 7 spaces away. 1, 2, 3, I know this goes up to 8. So that's C prime, that's B prime. And then A is 1, 2 spaces away, so 1, 2. That gives me A prime. And there we go. That is a reflection. And like I said, that's basically the straightforward way of doing it. If you come across something with the x-axis and the y-axis, um, honestly, counting is the best way to go. The only part that stinks is that now you have to like count out exactly where all the points are. So in this case, A is going to be 1, 2, 3, 4, -4, and then -2. Point B is going to be 1, 2, 3. I know it's going to be 4, and then -7. It's going to be 4 because we're reflecting about the x-axis. The x position isn't going to change. It's just going from +7 to -7. So it's going to be 4, and then -7, and then C is going to be the same thing. It's going to be in the same x position, so 5, and then instead of 1, it's going to be -1. So that's how we would map it out. So like I said, the first way is relatively straightforward. It's basically you do a graph and then you do a graph of the original drawing, you count up how far away all the different components are from the line, and then you just redraw the picture however it appears on the other side. There is another way to do it that's a little bit more, I'm not going to say intense, but it requires a little bit more memorization. It requires a little bit more practice. So let's say we're going to reflect this about the y-axis. So we're going to create an image with vertices 1, 2. So that's 1 up 2. So that's P. Q is 2, 5. So 1, 2, 1, 2, 3, 4, 5. That's Q. R is 8, 3. So 8, 1, 2, 3. I know that this whole thing is 8, so that's why I'm able to do it as quickly as I am. And then 7, 0, so that puts it right here. And PQRS, there we go. And again, the high quality drawings that we're doing here. So we've got P, Q, R, and S. Now we're going to need to find the primes. Like I said, we can do the original way, which is just counting over the spaces and counting how far away they are from here, and then just replot, and then replotting those points based on where these points are. But you don't always have access to the graph paper. You're not always going to have access to it, or you may not want to do all that extra counting, because is there a simpler way? Yes, there is. The rule is, if you're revolving around the y-axis, and each of these has their own rule, each of these has their own procedure. If you're revolving around the y-axis, if you start with x and y as your pre-image, you end, and again, this is across only the y-axis, negative x and y is the image. So the y isn't going to change. The y is going to stay the same, but the x is going to go from whatever positive it is to whatever negative it is. So let's see what that looks like. With point P, that's going to be negative 1, 2. With Q, that's going to be negative 2, 5, because again, for x and y, we're going to switch to negative x and y. So Q is 2 and 5, so that means Q prime is negative 2 and 5. R, 8, 3 means that R is going to be negative 8, 3. And then S prime is 7, 0. That's going to be negative 7, 0. So what I've done is I've taken advantage of this transformation, of this rule, and I've gotten my primes. I've gotten my prime notation. Now let's see what it looks like on the graph. So I've got 1, negative 1, 2, 2. I've got negative 2, 5, 1, 2, 1, 2, 3, 4, 5. I've got negative 8, 3, which is that one. And I've got negative 7, 0. And not bad for hand drawn. So that's kind of the trick. There are, as far as I can tell, as with my research, there are 6 rules when it comes to reflection, and the best way that I can describe it is that you just need to practice them and memorize them, and they make reflection so much easier. You can always just pick a line and then count, but honestly, these tricks make this work a lot easier. Let's go back to the x-axis. What would a rule be for the x-axis? For this one, for every x and y you start out with the pre-image, you would do the translation, and that one would turn into x negative y for the image, which is what we came up with. So you take a look, we got negative 4, 2. That means that x would stay the same at negative 4, but 2 would become negative 4, negative 2. B is 4, 7. X would stay the same, 7 would be negative. Okay, there we are. And then C, 5 and 1, x would stay the same at 5. 1 would be negative 1, and there we are. So it's just a general rule to help move things along, to help speed this up. So you can find all the points. So this way, using these methods, using these transformations, you can find all the points ahead of time. And it saves you a lot of time with counting. It saves you a lot of time with remembering. When it comes to x-axis and y-axis drawings, that's really not, you kind of have your choice about what you want to do and how you want to do it. It's when you get into some of the more complicated drawings that these tricks, like these transformations, become a lot more valuable. Like with these drawings. Let's say that we want to take the triangle JKL with vertices at J at 1, -1, so that's 1, -1, and then K at 2, 3, 1, 2, 1, 2, 3, and L, 3, -2, 1, 2, 3, -2. All right, I'm going to draw my line there, but we want to revolve it around x equals 4. So I've got 1, 2, 3, 4. This is the line that I want to revolve it around. This one I would honestly recommend. It would probably be easier to just reflect the dots because of how close they are to this line. And so in this case, it would be this dot here in this position, and then this dot is 1, 2, 3 away from the x-axis, so 1, 2, 3 here. And this one is 2 dots away, so that's 1, 2. And honestly, with something like this, that's what I would probably recommend that you do if you have the ability to. The transform, if you have the ability to do that with the drawing, with the graph paper. The rule, if you want to do something like this, is that if x equals a, then what you do for every x and y, do the transformation. You know what? I'm gonna do it over here because I need more space. For x equals a, for every x and y coordinate that you start with, you're going to do the transformation, and you're going to end up with 2a minus x, and then y is going to stay the same. So let's first of all, let's just visually identify what these points are before we start doing any calculations. So this first one, I really wish I'd labeled these. So we got J, and then K, and then L. Alrighty. So J prime should be this one over here. So it's going to be one. So it's going to be 1, 2, 3, 4, 5, 6, 7, -1. K is going to be 1, 2, 3, 4, 5, 6. Oh, wait. 1, 2. Using the x-axis, so 1, 2, 3, 5, 6, and then 1, 2, 3. That's K prime. And then J prime. And then L prime is going to be 1, 2, 3, 4, 5, and then -2. So that's probably the fastest way to do it, especially if you're expected to draw things too. But let's do with a quick calculation just to see if it holds up. So for x and y, 2a minus x, y. Well, let's take a look first at all the y variables to see if they change. So because with this transformation revolving around x equals 4, the y variable should stay the same between each of the points. So I've got -1, -1. I've got 3, I've got 3, I've got -2, I've got -2. All right. So that part of this transformation holds up. What do we do next for this? We're going to take, we've got x equals 4. So what we're going to do is we're going to take 2 times a, which is going to be 8, and I'm going to subtract whatever this x value is, and that should give me, so it's going to be 8 minus whatever this value is, and it should give me the new point. So starting with 1, 8 minus 1 should give me 7, gave me 7. 2, 8 minus 2 should give me 6, gave me 6. The 3, 8 minus 3 should give me 5, gave me 5. So that is another way that you can calculate out what the prime points are if you don't want to just count them up visually. For the sake of time, I'm going to use the I'm going to use a different transformation for y equals -5, but instead of drawing it, I'm going to draw them out first. So I've got 1, 2, 1, 2, 3, 4, 5, 6, and then 8. Oh, I already have m there. Sweet. So I got -1, and then -6. 1, 2, 3, 4, 5, 6. That's going to be n. Then I've got p, -2, -8. So 1, 2, -8 gives me p. All right. Around y equals -5. So I got 1, 2, 3, 4, 5. So we're making our reflection off of this line here. Not surprising. I would recommend when you're doing something like this and you have access to the graph, just count the points and then flip it over the image. But I want to make sure that these kinds of transformations can actually work. So if you have y equals b, for every x and y, you do the transformation. X is going to stay the same, but y is going to be 2b minus y. All right. So if b equals -5, well, you know what? Let's hold off. We'll start going point by point here. So the x values aren't going to change. That's going to give me -6. N is going to be -1, and then p is going to be -2. So it's the y values that are going to change. So it's going to be 2b minus y if b equals -5, so it's going to be -10 minus y. So -10 minus -8, -10 minus -8 is -10 plus 8, so it should be -2. Let's see, and there it is. -8, wait, -10 minus -6 is going to be -4. So n is going to be -4. And then p, -10 minus -8 is the same as -10 plus 8, which is -2. All right. So I've got these points. I've just calculated these points cold. Let's see what it looks like when I draw them out. So 1, 3, 4, 5, 6. I'm going to draw m first. 1, 2. Gives me m prime. Then I'm going to do n, so -1, and then 1, 2, 3, 4. It gives me n prime. And then p is -2, -2. 1, 2, 1, 2. P prime. Mm, mm, mm. It looks a little busy there, but it actually shows up better on camera than it does to my eye. But yeah, that's a reflection about y equals -5, and I did it by using this little rule here. And I'm going to get them on a table for you somewhere so you can take a look at them. But that is how you would do a reflection across this. Well, we've got some other problems on the back. Oh my goodness, we got several problems on the back. All right, so we've got lines y equals x, and oh, there we go. We've got lines y equals x and y equals -x. Not surprising. I've got rules for you. For y equals x, for every x and y, you do the transformation. And for y equals x, you're going to end with yx. So whatever your x value is, that's going to be your new y value. Whatever your y value is, that's going to be your new x value. And for y equals -x, rule is for every x and y, you do the transformation. The result is going to be -y, -x. So every x is going to change into -y, whatever y was, and then y is going to change into -x, whatever x was. So let's take a look at what we've got here. So I've got x, y, and z. I've got -5, 2. So 1, 2, 3, 4, 5. Hang on. -5, -2. 1, 2, 3, 4, 5. Is that? There we go. So that's x. And then y is 1, 2, 3. And then 1, 2, 3, 4. That's y. Then z is 1, -1, 1. So that's z. And we're drawing a triangle here. And we're looking at a reflection about y equals x. So that's a very crudely drawn y equals x. All right, well, let's calculate the points first. Let's figure out what the points are going to be first before we go on. So for x, because we're doing y equals x, we're doing this translation here. So for x, -5, -2, x prime should be -2, -5, because I'm just doing a straight swap. Yeah, just doing a straight swap. I'm not doing anything else. So for y, -3, 4, that means that y prime is going to be 4, -3. All right. And then for z, -1, 1, that means that z is going to be 1, -1. All right, let's see how this matches up. Let's see what our reflected image looks like when we do this. So x prime is going to be 1, 2, 1, 2, 3, 4, 5. And it gives me x prime. Y is going to be 4, 3, negative 3. So 1, 2, 3, 4, 1, 2, 3. Then Z is going to be 1, negative 1, 1, negative 1. I don't know. Looks pretty good to me. Um, yeah, it looks pretty good to me. So we'll move on to this one. Now we've got square ABCD with the vertices at negative 1, 3. So negative 1, 1, 2, 3, 0, 6. So we've got 0, 1, 2, 3, 4, 5, 6. I've got 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. And then 2, 2, 1, 2, 1, 2. This is a pretty oddly shaped quadrilateral, but who am I to judge? Pretty oddly shaped square, actually, but yeah, 2, 2, negative 1, 3, 2, 3, 4, 5, yeah, and then, okay, well, there we go. Just an oddly shaped square, quadrilateral, and we're going to be going about y equals negative x. So if you remember what the rule is, I'm just going to write it out over here. Transformation makes it into negative y, negative x. So we're doing what we did with y equals x. We're just making it negative as well. So what this means is, let's take a look and we'll go point by point. If a is negative 1, if a is negative 1, 3, that means that a prime is going to be negative 3, 1. Because I'm swapping the values and then I'm swapping their signs too. So if a is negative, if the x is negative 1, that means the y is going to be positive 1, which is what I've got. B, 0, 6. Well, thankfully, that means it's going to be negative 6, 0, and I don't really have to worry about the negative sign for a 0. C is 3, 5. That means that C prime is going to be negative 5, negative 3. Again, I'm just doing this rule here, where if you're reflecting along y equals negative x, x becomes negative y, whatever y was, and then y becomes negative x, whatever x was. Let's see, and then we get to D, which is 2, negative 2. Oh, well, that's easy. Negative 2, negative 2. All right. Now let's see what this image looks like. Let's start with A. I've got negative 1, 2, 3, 1. And I'm not going to label my points because I think it's going to be pretty evident if I got this right. Next is going to be negative 6, 0, 1, 2, 3, 4, 5, 6. C is negative 5, negative 3, 1, 2, 3, 4, 5, 1, 2, 3. And then D is going to be negative 2, 2, 1, 2, 1, 2. 6, 0, negative 3, 1, 2, 3. Ah, that's what it is. It's not negative 3, 1. It's negative. There we go. All right. Let's map it one more time. Let's map it one more time just to be 100%. So if I've got x and y, that means switching them around to 3 and negative 1. So that would be negative 3 and positive 1. All right. So A is going to be, let me map these out. Negative 1, 3. That's going to be A. Then B is 0, 6. 1, 2, 3, 4, 5, 6. Yeah, that's B. Then C is going to be 3, 5. Then D is going to be 2, 2. All right. So A prime is going to be negative 3, 1, 1, 2, 3, and then 1. It's going to be A prime. And so I guess it is important that you label your points. Let that be a lesson to you. B is going to be 0, 6, so that means that B is going to be negative 6, 0. So I got 1, 2, 3, 4, 5, 6, 0. C is going to be 3, 5, so it's going to be negative 5, negative 3. Yep. 1, 2, 3, 4, 5, 1, 2, 3. And then D is going to be 2, 2, so that's going to be negative 2, negative 2, 1, 2, 1, 2. I think I mapped this first one out incorrectly. B is 0, 6, 3 is... Oh, this is a little embarrassing. Let's see. Why did I figure this out? So negative 1, 3, all right. B is going to be 0, 6. Oh, I can't believe I did that. All right, that explains a lot. So my original drawing, my original thing, the original points, 0 is the x-coordinate. So 1, 2, 3, 4, 5, 6. That's B. And then C is 1, 2, 3, 1, 2, 3, 4, 5. And then D is 2, 2. Oh, there we go. That looks much better. Well, a little bit of a wave of panic there because I've already recorded a lot and I didn't want to have to redo it. But yeah, there we go. So the transformation holds true. Just make sure that you draw it right the first time. So, like I said, and I'm sure I've said this several times, don't be in a rush. Um, Try to do it right the first time, as you can see. Um, yeah, so the transformation works. All right, let's do the transformation across the y-axis. So remember, for the y-axis, x and y, the transformation is going to be negative x, y. So I'm just going to go on and I'm going to do the points just straight off. So first thing, I'm going to draw it first. So 1, 2, 3, 4, 5, then negative 2, 1, 2, negative 2, negative 2, 1, 2, 1, 2, 0, negative 6, so that's 0, 1, 2, 3, 4, 5, 6, and then negative 8, negative 6, so that's negative 8, 1, 2, 3, 4, 5, 6. All right, so that gives me a trapezoid, and I do have a trapezoid. I'm going to be reflecting it about the y-axis. All right, so all that means is for all these points here, I'm going to take the negative x and then but keep the y as it is. So for f, negative x is going to be 5, negative 2, because the y doesn't change. For g, it's going to be 2, negative 2. For h, it's going to be 0, negative 6. So, all right, well, there we go. And then for I, it's going to be 8, and then negative 6. Okay, let's map this out. So I've got 1, 2, 3, 4, 5, 1, 2. Got 1, 2, 1, 2. That's point B. Point S at point G. H is the same, and then I is 8, 1, 2, 3, 4, 5, 6. All right, looks pretty good to me. And I mapped out the points correctly this time. Hooray! So for this one, parallelogram with vertices at C, D, E, and F at y equals 2. So I'm going to make sure, yeah. So this is the axis we're going to be reflecting it about, y equals 2. So starting with negative 4, negative 4, so I've got 1, 2, 3, 4, 1, 2, 3, 4. Let's see. D is negative 2, 0, 1, 2. E is 6, 1, 1, 1, 2, 3, 4, 5, 6, 1. Aha, got it. 6 and 1. There we go. Positive 1, positive 1. And then F is 4, negative 3, 1, 2, 3, 4, 1, 2, 3. So we're making a parallelogram. Alrighty. Let's make ourselves a parallelogram. And then, let's see, E and F. Alrighty. We're just going to do a basic, we're going to do the same transformation as I did before, where if you have y equals b, which is what we've got here, then for every x and y that you have, you're going to do the transformation. X is going to stay the same, but you're going to get 2b minus y. B is going to be 2. So that means that we're going to take 4 minus our y variable is going to be our new thing. So x isn't going to change. So that's going to give me negative 4, negative 2, let's see, 6, and then 4. But now it's going to be 2b minus y. So 2 times 2 minus whatever y variable it is. So it's going to be 4 minus whatever y is. So 4 minus negative 4 is the same as 4 plus 4, which is 8. 0, 4 minus 0 because 2b minus y equals b equals 2. 4 minus 0 is 4, so that's going to be b. Going to be negative 2, 4. Yeah. E, we're going to have 6, and then 4 minus 1 is going to be 3. And then F, 4 minus negative 3 is going to be 4 plus 3, which is 7. All right, let's see what this looks like. So I've got 1, 2, 3, 4, then 8. I've got negative 2, 1, 2, 3, 4. I've got 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. Then 4, 7, 1, 2, 3, 4, and then this one's 7. I like it. Looks a little kind of wiggly here in the middle, but you know, who doesn't have a little wiggle in the middle, you know? All right, 2 more. And we are set with the worksheet. I'm definitely going to write these translation rules on the back of the board, so don't worry about needing to remember them. It'd be great if you did, but you don't need to worry too much about it. If I can write the exponential rules for algebra class, I can write these transformation rules for my geometry class. All right, rectangle. Great, we got 4 vertices again. All right, and we're revolving around y equals x. So is the line that we're working with. G is 2, 1, 2, negative 1, so 1, 2, negative 1. H is 7, negative 1. I is 7, negative 4, 1, 2, 3, 4. And then J is 2, negative 4. 1, 2, 1, 2, 1, 2, 3, 4. Oh, okay. I'll just, here we go. All right, a very, very nice, respectable looking rectangle. Now again, when we're dealing with transformations of x, y, with y equals x, we're translating it into y, x. So whatever x is, so x becomes whatever y is, and y becomes whatever x is. So we're just doing a straight swap of the 2 points. So for G, we've got negative 1, 2. For H, we've got negative 1, 7. For I, we've got negative 4, 7. And then for J, we've got negative 4, 2. Not having to graph these is going to make the bonus questions, I imagine, just fly right by. But hopefully by now you'll see that there's a proof, but there's adequate proof for these transformations here. But anyway, let's start mapping. So we got negative 1, 1, 2. We got negative 1, 7. Then we've got negative 4, 7. So 1, 2, 3, 4, 7. Then negative 4, 2. All right, looks pretty good to me. Reflected about the y equals x axis. All right. And the last one on the worksheet. Remember, for this one, we've got x, y. And if we're reflecting it about the y equals negative x axis, y equals negative x axis, there we go. Then that means the transformation is going to be, I think it's, yeah, negative y, negative x. So whatever x is, so you change x into whatever y is, but you take the negative. Change y into whatever x is, but you take the negative. So let's take a look. We've got negative 1, negative 6, negative 1, 1, 2, 3, 4, 5, 6. Got 0, negative 3, 1, 2, 3. And then 3, negative 4, 1, 2, 3, 1, 2, 3, 4. Ooh, all right. All right, so again, we're going to flip them, and then we're going to change, we're going to flip the variables, and then we're going to change positive into negative. So S prime becomes 6, 1. T becomes 3, 0. And then U becomes 4, 3. 4, negative 3. All right, so let's get started. 1, 2, 4, 5, 6, 1. Next one is 3, 0. 1, 2, 3. Last one is 4, negative 3. 1, 2, 3, 4. 1, 2, 3. Yeah, that's oops, there we go. That's actually a good reflection. What it is not good is the drawing the line of y equals x down there. But yeah, that is a good reflection following the same rules of reflection that we've had so far. So yeah, that is reflection. It's a little bit burdensome when you have to do some of the graphs, thankfully you've got a procedure, you've got a process, and you got some transfer. Excuse me, I apologize. You got some transformations that you can use that help make picking out the points a lot easier. So yeah, there we go. That is reflection. Oops.